So welcome back. This is part 6 of Negative Sequence Made Easier. In this one, we're going to go over the BE1 47N relay. This is a Basler relay. This is a negative sequence voltage protection. This is the first one that we're going to do that is actually a negative sequence calculation. And I'm going to find a way to make this much easier for you guys because we do have some really hard ones later. And some of them get really stupid with the math. I'm going to have to make multiple videos just for one of them. But on this one, we don't because we have a trick up our sleeve. So first, we need to do like we did in the last one. You need to actually read. This is a solid state relay, so it has only certain parts in it. You can't change certain stuff. So you need to read the manual, and it tells you what this part number is. So what is our nominal voltage? Well, it says that this position right here, 3 is a nominal 120 volts. That's nominal voltage, okay? And then we have other parts or positions for this part number, the style number. For example, our timing, okay? Our timing on this one is alpha 1. That's what it says right here. And that means that it's an instantaneous relay. So we have no time delay. Time delay is not there, okay? All we're going to have is just a pickup on this one to really test. Power supply is listed right here, which is the next one, and that's listed as a P. And so a P is 125 volt DC. 125 volt DC is the power supply for this relay. Okay, so make sure that you read your part number because this is usually one of the number one ways that relays get smoked. Now, in the manual, I went over and showed you briefly on the researching video, which I believe was part 3. And so in the manual, they have all of this, and they kind of explain how they do their line-to-line voltage. So they only have 3 terminals. They have an A, a B, and a C terminal on the back of the relay for your voltage connections, okay? And they don't have a ground terminal. So what they're trying to do is apply this to a delta protected system, which doesn't have, ground terminals, but they're doing negative sequence using line-to-line voltages, okay? That's what they're doing. And so the way that they did this is actually kind of neat. They said, well, how about this? How about if I wanted to test this relay, what could I do? What if I wanted to, I have VA, VB, and VC terminals on the back of the relay, okay? Just imagine this is the back of the relay. And they want a jumper B and C. They're just going to put a jumper across them. They're going to take a variac, an AC source, and what they're saying is and if you read the literature on this, I'm trying to give you the shorthand version. If we apply our one terminal of that AC source here and the other terminal of that AC source here, what voltage could we apply to get a negative sequence trip? At some point, this thing is going to trip on negative sequence. Now, if they had positive sequence and zero sequence, obviously it's going to have some of all of them, right? But what would it be for the negative sequence trip? And so what they do is they just basically say, this is just playing around with the math a little bit. This is your line-to-line, this whole equation right here is your line-to-line negative sequence calculation. And they're saying, well, if VB to C is 0 volts because we jumpered it out over here, right? Then we also know VC to B is 0 volts, which is equal to VB to C. And, if you were going to say that, then what about VA to B? Well, that's going to be our variac voltage. But isn't that the same as the negative of VC to A? And so that's what they're getting at right here, okay? Because all they're doing is they're just changing the terminals from, instead of VA to B, this is equal to VA minus VB. That's all it's trying to say. And so if we know that VB to VC is the same, then we can do a little bit of manipulation. So if you try to follow the math with this and what they're doing, that's what they get. And if you say that it's a negative 180 degrees, that's because it's a negative angle right here, or negative direction. Anything that's flowing in the positive direction, the negative direction is 180 degrees from it. So that's what this 180 and this negative come from. And so when you get all of that and you substitute in, because you don't have a VBC and a VCA, but you do know what they're going to be, what the equivalent of them is going to be, because you jumpered these out. So you can get this back substitution, put it into here, and then narrow it all down. And the manufacturer did all of this in the manual, and they're basically telling you, hey, this is your V2 line to line is equal to this. Okay. And so on the next page right here, what does this mean? This means I can take my VA, VB terminal, and VC terminal on the back of the relay. I'm going to draw my little diagram again. And I'm going to have an AC source. I'm going to apply this to VA. I'm going to jumper out VC and VB. I'm going to wire them to the other side of the source. Okay. And if your nominal voltage on the front of the relay was 120 volts, like they said, and your pickup was 0.2, okay, you're going to put all this into the equation, and your final answer, what is the voltage across VA to VB? Well, it's 41.56. All you have to do, they've given you this right here. You just do VA to B voltage, or the voltage of this source right here. What you're going to apply, it's the setting percentage times the square root of 3 times nominal voltage. Okay, and that setting comes from the front of the relay right here and this setting right here. The other two settings, this is for over voltage, this is for under voltage. We don't care about those. All we care about is this negative. I mean, you are going to have to test those, but that's not what we're talking about here. What we're talking about here is just this pickup, and this is the percent of setting. Okay, and so A on this one is 2. Well, in this situation, this would just be 0.02, which is 2%, times the square root of 3 times nominal voltage, which is 120 volts. And if you do the math and you multiply it all out, what you get is 4.156 volts. And so you could just apply that variac, and right around this threshold, this the relay should pick up for a negative sequence. So what's the point? The manual already gave you everything that you need. Again, this just proves, read the manual and use it. Okay, the old manufacturers, they gave you plenty of test methods because they knew that they had a lot of technicians out in the field with variacs. They had to give them resources to make them make their lives easier, because they probably kept getting a lot of calls asking for help. Okay, so they have all these in the manual. Quite often, most relays do, and you just have to read a little bit, and it'll tell you probably some very simple procedures to test their relay. Now, you might run into some newer relays, and they say, you don't need to test this, and the customer's like, I want you to test this. Well, then you might have to figure something out. But in this situation, I would definitely just go with what the manual gave you and use that. It's super easy to test, makes your life so much easier. So hopefully that helps, and I'll see you in the next one.